Okay, now let's try some questions in 1.4. Okay, first question 1.4. Now, the level of A and B, let's just take a look at this B. You must have already tried these questions. This level is very easy because you simply just plug the number into the formula because S9 must equals to A1 and 1 minus r to the power of 9 and divided by 1 minus r. So you know A, you know r, and then it's just a tedious calculation. So that's not something that's important. But however, when we get to question D, the level of difficulty raised a bit. So now here, because we don't know R. So if we do not know R, how can we calculate the R then? Now here, they use T4. As I always say, I just use A4. So A4 equals to A1 and R to the power of 3, right? Now I know A1 and I know A4, so I plug the number in here. A4 is 27, so that's 27, and A1 is -8, all right? And then I got R3, okay? So then I'm going to divide it both sides by -8, okay? So now turn out to be R to the power 3 equals to -27 over 8. Now again, using your number sense that you would understand, 27, that is 3 to the power 3. 8 is 2 to the power 3. So that means R3 equals to -3 over 2 to the power of 3. Oh well, again and again, if the power is the same and they're equal, then that means the base must be the same. So R equals to -3 over 2. Okay. Another question I find interesting is this one, H. Okay, H. This level of difficulty now raised a little bit more, as we all know that the workbook arranged in the way that always from the least difficult ones to the most difficult ones. So some of you must already develop this work habit that you try a couple of questions in the beginning, you try a couple of questions in the end, you might find something in the middle that's interesting, and that's more than enough, right? And usually this one and this one kind of like a mirror image to this, but this two not necessarily looking exactly the same, but how to pursue it might be the same. I just tried H. All right, so now H, what's going on here? Here says S3. S3 now equals to A, which is A1, 1 minus R to the power of 3 divided by 1 minus R. All right, so now in this case, we know S3, we know A. So let's put this number in to see what's going on here. So that means 39 equals to 3 multiplied by 1 subtract R to the power of 3 divided by 1 minus R. Okay, well, on both sides, I'm just going to divide it by 3, right? Of course, I can do that. So the 3 is gone, and this divided by 3 is 13. All right, so now my equation becomes 13 equals to 1 subtract R to the power of 3 over 1 subtract R. Okay, well then move this one to the other side, or another way to say is multiply by 1 subtract R. Okay, and then this cancels. Then over here is 13 multiplied by 1 minus R equals to 1 minus r to the power of 3. Okay, well, there's nothing you can do about but distribute it. So that becomes 13, subtract 13r equals to 1 minus r to the power of 3. Okay, well, organize it into a polynomial function or equation because here we got the power of 3. So it's a degree of 3 polynomial function. So then let's reorganize it. Okay, move these two to the other side. That becomes r to the power of 3, subtract 13r. And now this is 13 subtract 1. That means plus 12 equals to 0. And use the factor theorem. And pretty much by number sense, you know r equals to 1 is a factor because they become the 1. 1 plus 12 is positive 13, and this is negative 13. Sure, positive 13 is 0. So that is. So use this to divide it by, so this whole thing now, to divide it by r minus 1. All right? So that means you now have a factor which is r minus 1 after either you do synthetic division or long division, doesn't matter what it is. Then you have, I just divided. Where did that go? You have this r equals to, let me just find my division, r equals to r squared plus r subtract 12, and that equals to 0. All right, so then in this case, now r minus plus 4 and r minus 3 equals to 0, and there's also r negative 1 here. So that means r equals to negative 4 or r equals to 3. The reason why this one does not even need to be in consideration is because if r is 1, then everything's the same. So obviously this is not the same. All right. So that is either r is this, is either r is that. Okay. What is next? Oh, okay. This one, I find this just very tedious. This very tedious calculations, all the numbers. If you tried a couple, you know what to do, and then just don't worry about it. I just find this number, there's sometimes 1 over 5 to the power of 10. Oh, wow. So anyways, you use your calculator, you will get it. Okay. This question number 4, I find that interesting. Okay. This one's straightforward. Go figure it by yourself. But I like to demonstrate this one. Okay. So this one, what we know is, well, of course, we know A1. So this is our A1. And pretty straightforward that we know the r, because r equals to your next term, so negative 6 divided by 2. So your r is negative 3. So we know that. But in order to know the sum, so sure, doesn't matter what you wanted to use, you have to, you're the sum as the sum. So you needed to know the n, right? You need to know the n. So you do know this last term. Last term is given. So the last term, an, is 13122. And also an also equals to a1 r and minus 1, right? So we know this number, so 13122. We also know a1, which is 2. We also know r, that is negative 3 to the power of n minus 1. So again and again now, this is in the power. So we just have to use our strategy to somewhat got the base and the same base and have a power on this side so that we can calculate the n. So now, first of all, divided by 2 on both sides. And obviously, this is an even number. So, of course, can be divided by 2. So that is gone. So now the base is negative 3 on right-hand side. And then this one divided by that is 6561. All right. Now 6561, divisibility, using divisibility, you can divide it by 3. You can use here, I talked to a couple of students, you can always use factor tree. You can always use factor tree. Just divide it by 3, divided because you needed to figure out the negative 3, right? So just divide it by 3, divided by 3 to see how many 3 here or how many negative 3 for that matter. But if some of you would have a better number sense, that means, well, why don't I try 81? So if this one divided by 81, what does that happen? And use your calculator, 81. Oh, you understand this is 81 to the power of 2. We don't not there yet because 81, but 81 right away, you know 81 has 3 as a factor. So just let's be a little bit patient here. So then 81 means 9 multiplied by 9. 9 multiplied by 9 means 3 multiplied by 3 okay, so that means 9 multiplied by 9 to the power of 2. This one is still over here. And then this means that and that. So that means 3 and 3 and 3 and 3 to the power of 2. The right hand side is the same thing. All right. So that also means this is 3 to the power of 4 and to the power of 2 and equals to the right hand side. Okay. And then because all even power, so I can write negative 3 to the power of 8. That is negative 3 to the power of n minus 1. Bingo! That means n minus 1 equals to 8, n equals to 9. All right? The only thing here is that when you write into the sigma notation, so sigma notation, that is this, and it says k equals to 1. That's the index of the first term. So k equals to 1. And then over here, it is 2 multiplied by negative 3. 2, if we start with k, then that is not the first term. So that has to be k minus 1. All right? So if this is k minus 1, then this 9 should be, if you plug the 9 here, you use this to calculate, is not that. So this should be 10. Okay, so that's just verify. So if that's a 10, so that means that is 9 to the, that means this is a 10. So take a look at that. So a 10, it is 2 negative 3 to the power of 9. All right. So now here we said that negative 3 to the power of 8, that is 6561. And then we multiply by 3. So you have to just to try to see whether or not this gives you this number. All right. Hold on for a second. So this is 9. Sorry. This should be 9 because this is already 9. So this is basically, this is 8, right? So this is 8 and this is 8. Then I give you this one. You multiply by 2, then that is that. All right. Sorry, I don't understand why I said this is 10. Okay, so let's just, because this is 9 here. All right. So that is a way to do this. And if you're interested, try this question. and then try this question. Okay. What else I thought that was interesting? Okay. All right, so now this question is very classic. It's a very classic question. And in my teaching video for 1.4, I already demonstrate this question. So pay attention to this question, please.